This screencast is going to look at how your heart beats. I'm going to look particularly at the cardiac cycle and then how is that cycle controlled in terms of its speed. When a doctor asks to listen to your heart rate, they use a stethoscope and they get a sound which is probably very familiar to you. Dub dub, dub dub, dub dub. If someone were to do that to you, you'd automatically assume that they're talking about, I think, the heart rate. Now, we've got to break that heart rate down into three parts. There's the quiet, the lub, followed by the dub very quickly afterwards. These three sections make up the three parts of the heartbeat in itself. I'll start my description of the actual cycle with the quiet bit. I've called this, but in reality it's called the diastole. The diastole is a period in the heart where all the muscles of the heart relax. This relaxation increases the volume inside the atria and inside the ventricles, reducing the pressure, and therefore draws blood into the heart from either the vena cava into the right side or from the pulmonary veins on the left side. At this point, the valves between the atria and the ventricles are pushed open because of the blood flowing through them. The valves here which go up to the aorta or to the pulmonary arteries are left closed. The reason they're left closed is because the pressure inside this chambers of the heart are lower than the pressure inside the pulmonary artery and the aorta themselves. This pushes these semilunar valves shut. After the bit of quiet, which you don't really hear in a stethoscope, you get the lub. This is the atrial systole. Systole means contraction, and if it's the atrial, it's contraction of the atria. The contraction of the parts of the muscle here and here force the blood from the top of the heart down to the bottom of the heart in the ventricles. Obviously this is going through the atrioventricular valves, pushing them open. Then, after the lub, there's the dub. This is called the ventricular systole. This is again contraction, and it is in the ventricles. The ventricles contract and push the blood upwards. Because the blood's been pushed upwards, this closes the valve between the ventricle and the atria and forces open the valve going up into the aorta or up into the pulmonary arteries. Then the cycle starts again. You may remember this scene from the Indiana Jones movie, where the high priest takes the heart out of one of the slaves. While you're watching this, look closely at the heart itself and see what happens while it's in the high priest's hand. See, it's still beating a little bit. So how does that happen? The ability of the heart to actually continue to beat without any input from either nerves or from other chemicals is called a myogenic muscle contraction. The heart has an inbuilt rhythm, an inbuilt contraction. So how does this myogenic beat actually work? Let's take a look at the structure of our heart again. Obviously the heart itself has got a septum which divides it into two, the left and the right side, and you have the atrioventricular valves that separate your atria at the top from your ventricles down the bottom. If you remember when we dissected, this was a very, very distinct line in the muscle. It's quite important. We'll come back to that. Up in the right atria, there is a thing called the sinoatrial node, or the pacemaker. Oops. The pacemaker itself is the source of the beat. The beat passes out through the atria. As the wave of contraction reaches that atrioventricular separation, the wave itself cannot pass through to the ventricular muscles, but the wave will continue out across the other atria into the left side. This means that all of your atria will contract in one beat. Now remember I said that the atria and the ventricles beat separately. How does this happen? Well, in the septum between the atria there is a thing called the atrioventricular node. This receives the contraction from the muscle and changes it into a signal which it passes down some fibers called Purkinje fibers, running all the way down to the bottom of the heart. In the bottom of the heart, these Purkinje fibers branch out and also feed the bottom of the ventricles. As the signal passes down the Purkinje fibers, it doesn't stimulate any of the muscle that it passes. But when it reaches the branches, it stimulates these muscles to start the contraction. The contraction then passes upwards, pushing the blood up into, in this case, the aorta. This myogenic beat allows the heart to beat at somewhere between 60 to 70 beats per minute. Now this is fine if you're sitting down in a chair. However, if you're getting chased by a lion, you kind of want your heart rate to be able to speed up to deliver enough oxygen to your muscles. This happens under the action of a chemical called adrenaline, released from the kidney. The adrenaline passes from the kidney through the vena cava and reaches the pacemaker, where it causes the pulse rate to go up. Also, the body can make the pulse rate go up with the accelerator nerve. So if you're exercising and need more oxygen and your brain realizes that you need to have more oxygen, it sends a signal down the accelerator nerve to speed up the heartbeat. Again, the accelerator nerve links directly to the pacemaker. If you're sitting down in front of the television, not doing very much, you don't really need to have your heart rate quite so high. You don't have as much requirement for oxygen or the nutrients. The brain senses this, sends a signal down the vagus nerve, yet again to the pacemaker, which then has the impact of slowing down the pulse rate. Thank you.